This is Dr. K. Raghuram Mohan Reddy, Associate Professor, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. Okay, so the course name is Unconventional Machining Process. The topic name is Water Jet Machining Problems and Solutions. Right. So at the end of this session, student will be able to solve the problems on material removal rate of abrasive jet machining. Sorry, this one is water jet machining. Okay, right. So far we have discussed the various non-traditional machining processes which are under three main categories: mechanical, thermal, and chemical and electrochemical. Okay, so we have discussed ultrasonic machining and abrasive jet machining. Now we are discussing water jet machining. Okay, right. Problem number 1. Calculate water jet velocity. Okay, a water jet machining system operates with the following parameters: nozzle diameter, pressure of water, discharge coefficient. Calculate the velocity of the water jet as it exits the nozzle. Okay, so already we have the basic Bernoulli's equation. So from that, V equal to coefficient of discharge into square root of 2 times the power to the density. Okay, right. So this is the CD 0.98 discharge coefficient. Okay, so P is given. Okay, 300 megapascals pressure. Okay, 300 into 10 power 6 pascals. We have converted mega into just pascals. Okay, megapascals to pascals. Okay, and density we know. Okay, 1000 kg per cubic meters. Just substitute the values. Okay, so we get V. Okay, so that equal to this one. Okay, thus the velocity of the water jet as it exits the nozzle is approximately 759 per 1.1 meters per second. Problem 2. Material removal rate in water jet machining. In a water jet machining process, the following data is available. Okay, water flow rate, abrasive flow rate, cutting speed, width of cut, that is kerf, thickness of the material, density of the material. So calculate the material removal rate in grams per minute. Okay, so solution. So in water jet machining, the volume removal rate is cutting speed into kerf width into material thickness. Okay, so first we need to calculate the volume material removed per minute, and volume removal rate will be just substituting cutting speed, kerf width, and material thickness, so that we get this value. We need to convert this to cubic centimeters. Okay, so finally we'll get like this. Okay, so next calculate the material removal rate in grams per minute, MRR, that equal to volume removal rate into density of the material. Okay, right. Given the density of the material, MRR equal to, already we got 0.5 cubic centimeters, and just multiply with the density with grams per centimeter cube, so that we get this value. Okay, right. Problem 3. Power required in water jet machining. The water jet machining system operates with the following parameters: water pressure 400 megapascals, water flow rate 3 liters per minute, efficiency of the pump 85%. Calculate the power required to drive the pump in kilowatts. Okay, so solution P can be calculated using this formula. Okay, Q into pressure by efficiency. Okay, right, where Q equal to flow rate in cubic meters per second. Okay, pressure in pascals and efficiency of the pump. Okay, just substitute the values so that we will get the Q. Okay, so that is 3 liters per minute by 1000 into 60. Why? Because here how much efficiency is how much we need not okay, we need to find that one only. Okay, Q we need to find. Okay, see here per second, so we have to multiply with 60, right? Next, convert pressure to pascals. Okay, so here megapascals is given, so 400 into 10 power 6 pascals. Okay, and just substitute the values. Okay, so that we will get these values. So what we have done, first we have this formula. Okay, so here we need to convert into simple pascals, and Q we need to find, and efficiency is 0.85 given. Okay, efficiency is given. Okay, so this one is calculated Q. So finally the power required to drive the pump is approximately 25.53 kilowatts. Okay, right. Cutting time estimation. A water jet machining process is used to cut a sheet of metal with the following parameters. Length of cut is given, cutting speed is given. Calculate the time required to complete the cut. Okay, right. The time t required for cutting is calculated using t equal to length of cut to the cutting speed. Substituting the given values. Okay, length of cut is given, cutting speed is given. See here, length of cut is given, cutting speed is given. Okay, so length of cut, cutting speed given. So simple mathematics. Okay, so the ratio of length of cut to cutting speed, so that we get the time for cutting. Okay, so that is 0.5 minutes or 30 seconds. Problem 5. Energy utilization in water jet machine. A water jet machining system operates at a water pressure of 350 megapascals with a flow rate of 2 liters per minute. The actual power used in material removal is 15 kilowatts. Calculate the energy utilization efficiency. Okay, right. First, calculate the total power supplied. So we have the basic equation. Okay, so total power supplied equal to Q into pressure in pascals and by efficiency. Okay, so given Q equal to 2 into 10 power minus 3 by 60 cubic meters per second. Okay, why? Because see here 2 liters per minute. Okay, so that we have to convert this one into seconds. Okay, so that's why by 60. Okay, right. Here the pressure is converted into just pascals, okay, from megapascals to pascals, so that we get total power in kilowatts. Now efficiency equal to actual power used to the total power supplied into 100%. So the actual power used is 15 kilowatt and total power supplied is 11.67. So this is 128.6%. Okay. So utilization energy is percentage of utilization energy is very good. Okay. So this is the reference for these problems. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.